Hello again everyone, welcome back to ptet.chemistry channel. So my name is Mr. On, and in this tutorial video I'll continue this lecture tutorial which I call lectorial on atomic structure and the periodic table. So the big topic itself is called atoms, molecules and compounds, if I'm not mistaken. Used to be just atomic structure on its own, and then in the previous lectorial I covered specifically on how to differentiate and distinguish between elements, compounds and mixtures. So in this lectorial, I will specifically focus on the periodic table, which basically focuses on the elements essentially, right? So now that we know what elements are, from our previous definition of elements, elements consist of only one type of atoms. So elements contain only one type of atoms. They cannot be broken down into simpler substances by chemical method. Alright, so elements can be atoms such as these noble gases, which exist as individual atoms without a number subscript because they exist as individual one single atom. Just like these individual single atoms, they are not chemically bonded together because they are not compound. And then elements can also exist as molecules such as this nitrogen, oxygen, hydrogen, fluorine, bromine, iodine. They all have a number 2 at the bottom. That means they exist as a molecule because molecule can consist of 2 or more atoms that are chemically combined together. But molecule can also be an element. Molecule can also be a compound. So this is a molecule. Water is a molecule, but it's a compound because it has 2 or more different elements chemically combined together in a fixed ratio. Whereas when you have this molecule, which has more than one atoms, 2 or more atoms, but they are the same kind of atoms. So this is an example of an element which also happen to be molecule. Alright, this is an example of an element which are atoms. Going back to what I'm supposed to cover in this lectorial, we will have this particular learning objective where it says we need to describe. So you need to write down in detail. So describe is in detail. So it's not just stating the structure of an atom. So that's why the topic is called atomic structure. You have a central nucleus. So nucleus is the core. Nucleus is the core at the center of an atom. It contains neutrons, it contains protons, and you have electrons orbiting around in shells. The electrons are always moving, and they are not in the nucleus. They are surrounding the central nucleus in shells. Alright, we'll talk more about this later on. The next bit is basically stating. Stating means just give the value, just give the answer. Alright, relative charges and relative masses of proton, neutron and electrons, and we will cover this in this particular table, which I will fill in together with you. And that means that when the syllabus says state for each of these electron, proton, neutrons in whatever order that is, these values you need to know because the syllabus says candidates should be able to state the relative masses, state the relative charges. That's why when you revise you have to understand what the syllabus actually wants from you. 2.2.3 is basically define. Define is basically definition. So definition basically means what. But there are different way of asking definitions, and I'll go through a couple of examples as well as this kind of lecture tutorial video or lectorial. They are best supplemented by going through the checkpoint questions, which there will be a upcoming video tutorial on it as well. So what is proton number, also known as atomic number? We need to define it as the number of protons in the nucleus of an atom. Whereas there's another definition which is mass number or nucleon number. So the fact that they actually give you the alternate names mean that question can ask you on proton number or they can ask you on atomic number, but you need to know they are the same. They mean the same thing. And if they already stated in the syllabus, that you must know that they mean the same thing. So when they ask you using one term or the other one, you cannot blame them because candidates should be able to. That is what Cambridge say you should be able to. If you are unable to by looking at the syllabus, that means you haven't really mastered whatever you need to master. Just because you read through the contents of your notes or your textbook does not mean you have understood and mastered the content. So make sure you revise with the syllabus as a checklist of what you need to be able to do. Okay, let's get started. So previously we talked about an element consisting of only one type of atom. So an atom is the smallest particle that cannot be divided further. So it's the smallest indivisible particle of an element. As we know, elements cannot be broken down into simpler substances because it contains only one kind of atoms, and the atom is the smallest indivisible particle, meaning it cannot be further divided, it cannot be further broken up without losing its identity or its meaning. Alright, so the other thing is about the relative size and the actual size. So these things are just numbers to give you a feel for how small an atom is. If you have a small green pea, if you've never seen a blueberry, so in a football stadium that's quite big, that one small dot in the middle of the stadium is just how an atom would look like. Okay, so the actual size of an atom is actually very, very small. If you do physics, you will have heard of 1 meter is 10 to the minus 3 millimeter, is 10 to the minus 6 micrometer, is 10 to the power minus 9 nanometer, is 10 to the power minus 12 picometer. So that is equal to, hang on, no, that will be a plus, a plus, a plus, and a plus because I'm going from 1 meter. So that means 1 picometer is 10 to the minus 12 meter. But you get the drift, right? So you're going smaller and smaller and smaller. And when we talk about picometer, it's actually very, very small. So 1 picometer is equal to 10 to the power minus 12 meter. 1 meter is 10 to the plus 12. So 1 picometer is 10 to the power minus 12. This is just your simple mathematics conversion using indices. I think it's called indices in maths and lower secondary maths, as well as something you will be expected to do in physics, and there will be a little bit of maths calculations involved in O-level chemistry or IGCSE or whatever 14 to 16 years old chemistry content that you are doing. Okay, so in terms of what is actually required by the syllabus, these are not really required, they're just there for your references. We'll come back to this periodic table in a little bit. In terms of the subatomic particles, so previously the syllabus said you must know that the nucleus is at the center of an atom. So there's the center of an atom. What does the nucleus contain? The nucleus contains the protons and the neutrons. Okay, at the nucleus, together, nucleons. When you see this term nucleons, nucleons refer to protons and neutrons. Nucleons refer to whatever is in the nucleus. And what is in the nucleus? The nucleus is at the heart of the atom, is at the center of an atom. So this whole thing is atomic structure. Nucleus is at the center. It contains nucleons because it contains protons and neutrons. So nucleons are protons and neutrons. Be very careful, it's not just proton, it's not just neutron, it's nucleons because it's protons and neutrons. Electrons are found orbiting because electrons are always moving. This is a two-dimensional diagram, that's why it's drawn as a circle, but in reality we live in a three-dimensional world, so the electrons are in a spherical. Sphere is three-dimensional, okay? So sphere is three-dimensional versus circle, which is two-dimensional. On paper, we always represent it as two-dimensional, but in reality the electrons are orbiting in three-dimensional in a spherical manner around the nucleus. But look at the electrons are not in the nucleus, they are in a region of space, okay? They're in this region of space at a fixed distance from the nucleus, and the electrons are living there, they are moving around, meaning they are orbiting outside the nucleus, and they reside or they are arranged in this thing called electron shells, also known as energy levels. So electron shell is a key idea that we will talk about when we talk about filling in the electrons, and we will come to that in a little bit. The subatomic particles, basically atom is already really small, we can't see with the naked eye. What is inside the atom? This topic is about atomic structure. The nucleus contains the protons. The nucleus also contains the neutrons. Make sure you can spell this properly. and the electrons orbit around the nucleus in these electron shells. All right, this is called relative. Relative means it's a ratio. If you see what is going on here, the mass of a proton is really small. You think picometer was small, 10 to the minus 12? 10 to the minus 27 is even smaller, even though this is kilogram, but this is really, really small with a lot of 0.00000, a lot of zero. Okay, very, very small. You don't see the atom, but you can feel it because there are a lot of them. All right, so relative is just the ratio. So protons and neutrons are the denser one. They are heavier than the electrons, so they have the same mass. Their mass is not 1 kilo, their mass is not 1 gram, but because they have the same mass, the relative mass is going to be 1:1 because they have the same mass. Okay, these things are relative mass. They have no unit. All right, because if I say this is 1.67 times 10 to the minus 27 kilo, this is also 1.67 times 10 to the minus 27 kilo. But the syllabus specifically state relative masses, not the exact masses. So no need to know the exact number, but it's very, very small. This thing is not kilo, this thing is not gram, this thing is the ratio of their actual masses. Electrons are very, very light. It's around 1/1840. Some books will give it as 1/2000. Either way, if you put it into your calculator, these are going to be very small number. That's why we say electrons are so much lighter than protons and neutrons. Okay, so some people don't like to remember 1/840. 1/2000 would have been equally acceptable, although one way or another you will see marking scheme typically shows this, but I am almost 100% certain if you put down 1/2000, there's no way the examiners can penalize you because both of these are equally acceptable by the wider chemistry community globally. Relative charge, so these are based on experiments done by chemists back in the days. They have this thing called an electric field. All right, so when you have an electric field, and this is electrons are negatively charged. Okay, electrons are negatively charged. The electrons, so this beam contains protons, neutrons, and electrons. You fire them in the presence of an electric field. Electrons are negatively charged and is attracted. It's deflected because it's attracted towards this terminal. Negative attract positive, so this must be the positive electric field, which means this must be negative, which means what do we have? Which means we must have the neutrons. The neutrons must be there because it is not deflected, meaning it just goes straight because it is not charged. So neutrons are not charged, it has zero charge, and therefore it is not deflected because it's not attracted towards positive or negative, it just passes through straight away. How about protons then? Okay, so we will expect protons to be deflected. Okay, so protons are heavier, so they will be deflected lesser. Electrons are lighter, so it will be deflected more. So this will be protons because protons are positively charged. If protons are positively charged, they will be attracted towards the negative electric field, and therefore they're deflected upward towards the negative electric field. Therefore, this is negative. All right. I have a feeling that I have actually forgotten to put in the electric field, but judging from the direction of the electron beam, which is negatively charged, I know this is definitely positive, right? So the reasons for them are based on their relative charges, and this is the classic experiment to show that neutrons have no charge, protons are positively charged because they're attracted towards the negative electric field, and electrons are negatively charged because they're attracted towards the positive electric field. So mass and charge are different. Protons have a charge of +1, neutrons have 0 charge, as I mentioned, electrons have a charge of -1. These plus have to be shown, okay, even though this is a plus, this is a plus, this is a plus, you don't show it. But when you talk about charge, so charge has a meaning only when you have a plus or a minus, and when you are 0, plus or minus do not have a meaning. But when you have a whole number, which is not 0, you will have to put down the charge because it's asking for relative charges. Candidates should be able to state the relative masses and the relative charges for protons, neutrons, and electrons. And questions can rotate around whether you have electrons here or protons here or neutrons here, or in whatever order that they do, yeah. The syllabus also say you need to be able to define atomic number or proton numbers. These are definitions. So atomic number, also called proton number, is the number of protons in the nucleus of an atom. A lot of students will just know, oh, proton number, number of protons. But your definition is not complete. Where are the protons? The protons are in the nucleus of an atom. So make sure when you look at proton number, is the number of protons in the nucleus of an atom. So elements in the periodic table. As you see, this is a periodic table. They tell you that your periodic table is given in this format: atomic number. So atomic number is also known as proton number. You will see that the elements are arranged from element number 1, element number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and so on and so forth. Okay, that means it's in order of increasing atomic number. That means it's in the order of increasing proton number. And that means it's in the order of increasing the number of protons in the nucleus of an atom. Because that tells you the number of protons in the nucleus of an atom. The fact that you have a whole number, 3, 4, 5, 6, blah, 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 but we don't have 3.5, so there's no element in between here, because you cannot have a partial, you cannot have a fractional or partial or decimal proton number, because number of proton is just you counting 1, 2, 3, 4, 5. You do not have decimals, you do not have fractional, you do not have partial protons, and therefore that's why you cannot fit another element in between this whole number. They are all just whole number, and they are all continuously increasing by 1 proton. Number of protons in the nucleus of an atom. Atomic number, proton number. Okay, your periodic table will only tell you atomic number. They will not tell you its proton number, but your syllabus say you must know they mean the same thing. Mass number, on the other hand, is called nucleon number. So again, you need to know both the name. Mass number is the total number of protons and neutrons in the nucleus of an atom. Okay, so it's to do with the number of nucleons. All right, so if you don't like to use this term protons and neutrons, you can talk about nucleons, because define nucleon. What is nucleon? Nucleon refer to the protons and the neutrons in the nucleus of an atom. So what is nucleon number? Nucleon number is to do with the total number of nucleons in the nucleus of an atom. In nucleon number is the same as mass number, so it's the number of protons and neutrons in the nucleus of an atom. And why is it that it doesn't include the electrons? Because, well, nucleon refers to the nucleons in the nucleus of an atom, and also electrons are very, very light, 2000, or well, 1840 exactly, much lighter. Lighter means less heavier compared to protons and neutrons. So the bulk, the majority, the bulk of the mass of an atom comes from the nucleus, which comes from the protons and neutrons. Going back to the periodic table, you will see that this thing called relative atomic mass is actually the average mass of something, the definition of which is actually in your syllabus, and we'll cover it in the next, I think it's in the next lecture tutorial video, and you can wait for that, and I'll talk about it in the next lecture tutorial video. But what is important is also that the mass number or the nucleon number is this bigger number, whereas the periodic table arranges elements in the order of increasing proton number, but even though so it's increasing by 1 each time, right? And that is how the periodic table are arranged, but the mass number or the nucleon number is not increasing by 1 all the time. So this is 1, this is 4, this is 7 and 9, so there's an increase of 2, there's an increase of 3, there's an increase of 1. So it's unpredictable looking at the mass number, because the periodic table is arranged in the order of proton number and not mass number, even though the mass numbers is it seems like it's increasing all the time as well. All right. What else am I supposed to cover here? So we already finished all these four learning objective in this atomic structure and the periodic table. I think I'll leave it there for this lectorial, and I'll continue more in the next lectorial on this atomic structure and periodic table, where I'll talk more electronic configurations and how to interpret and read the periodic table further. All right, so thank you for watching, and ask me if you have any questions, whether in class or break time or whatever, or if you are watching this on YouTube, you can raise out any issues in the comment section. So do subscribe to the channel if you haven't, and share the channel with friends, chat group, and various other people you know who are doing 14 to 18 years old chemistry. That is O-level, IGCSE, GCSE, or A-level or IB chemistry. So see you in the next video.